Hello YouTube. In this presentation, we will see a high-level overview of machine learning fundamentals. Topics we will cover in this presentation are: what is machine learning? Why use machine learning? Types of machine learning system. Supervised and unsupervised learning. In supervised learning, we will talk about classification and regression algorithm. And unsupervised learning, we also cover a little on that. What is machine learning? The definition: machine learning is the science or an art of programming computers so they can learn from data. A general definition says machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. A more engineering-oriented definition says a computer program is said to learn from experience C for some task T and some performance measure P, if its performance on T, as measured by P, improves with experience C. Here the experience is the training data we provide to the algorithm. The task T is the prediction variable or the targeted output, and P is the accuracy on the testing dataset. An example of this definition is the spam filter. It is a machine learning program that can learn to flag spam based on given example emails. Here flagging is the task T according to the above definition. On example emails are the training dataset T flagged by previous users. Why use machine learning? In this section, we will see traditional programming approaches to perform a task, such as spam filter, also the machine learning technique to accomplish the same work. And then we will talk about some listed reasons where machine learning is great over traditional programming approaches. So let's see traditional programming approaches to writing a spam filter. First, the problem. We would study the problem. In this case, the problem is what the spam typically looks like. We might notice that some words or phrases, such as for you, credit card, free, amazing and so on, tend to come up a lot in the subject. Perhaps we would also notice a few other patterns in the sender's name and the email body. Then, the rule, we would write some rules or a detection algorithm for each of the patterns that we noticed in spam, and our program would flag emails as spam if a number of these patterns are detected. Finally, evaluation. We would test our program, and analyzing error, we would repeat steps 1 and 2 until it is good enough to filter actual spam. This whole procedure of traditional programming approaches we've shown in this diagram. As we can see in the diagram that our procedure of traditional approaches begins with studying the problem. Based on that problem we will write some rules, which is our detection algorithm. And then we'll code the algorithm. If we are happy with our program, then we will launch it for spam filter. And if we are not happy with the program, then we would analyze the error and repeat step 1 and 2 until our program is good enough to filter actual spam. But for this kind of problem, there are drawbacks in traditional programming approaches. Since the problem is not trivial, the traditional approaches will likely become a long list of complex rules and also pretty hard to maintain. Moreover, the drawback of traditional procedures is, if spammers notice that all their emails containing specific word patterns are blocked, then they might start using new word patterns instead. As a result, traditional programmers need to write new rules to block that word pattern as well. If spammers keep changing word patterns, programmers also need to keep writing new rules. Now let's see spam filter based on machine learning techniques. In contrast, a spam filter based on machine learning techniques automatically learns which words and phrases are good predictors of spam by detecting unusually frequent patterns of words flagged by previous users, which is the training dataset. As we can see in the diagram, we provide it to our machine learning algorithm. Thus the program is much shorter, easier to maintain, and most likely more accurate. We have listed here the reasons where the machine learning techniques is the most suitable. This technique is great for the problems such as spam filter, where existing solutions require a lot of hand-tuning or a long list of rules. So in this case, machine learning techniques can often simplify code and perform better. Machine learning is also great for complex problems for which there is no good solution at all using traditional approaches. The best machine learning techniques can find a solution. It is great for a variable environment because ML technique can adopt new data comfortably. And finally, we use machine learning also because it is great for getting insight into complex problems and a large amount of data. Types of machine learning systems. Based on whether or not they are trained with human supervision, ML system can be classified as supervised, unsupervised, semi-supervised, and reinforcement learning. Based on whether or not they can learn incrementally on the fly, we can define machine learning as online versus batch learning. Also based on whether they work by simply comparing new data points to known data points, or instead, detect patterns in the training data and build a predictive model, we classify the ML system as instance-based learning versus model-based learning. Let's see what's unsupervised learning. According to the amount and type of supervision they get during training, we classify the machine learning system into 4 different categories. In supervised learning, the training data we feed into the algorithm includes the desired solutions. A typical supervised learning task is classification. The spam filter is a good example of the classification problem. The algorithm is trained with many example emails along with their class, spam or ham, and it must learn how to classify new emails. Ham is here the opposite of spam, email that is not a spam. Another typical task is to predict the target numeric value, such as the price of a car, based on given a set of features, such as mileage of the car, age, brand, etc. These features are called predictors. This sort of task is called regression. To train the system, we need to give it many examples of cars, including both the predictors and their labels, the targeted numeric values, the car prices. Some regression algorithms can be used for classification as well, and vice versa. For example, logistic regression, true or false, is commonly used for classification, as it can output a value that corresponds to the probability of belonging to a given class. We have almost come to an end with this presentation. Let's finish this part by talking a bit about unsupervised learning. In unsupervised learning, the training data is unlabeled. It means that we do not provide the desired solution with training data. The system tries to learn itself without a teacher. An example of unsupervised learning, say we have a lot of data about our blog visitors. We may want to run a clustering algorithm to try to detect groups of similar visitors. At no point do we tell the algorithm which group a visitor belongs to, it finds those connections without our help. Some important unsupervised learning algorithms are clustering algorithms, that include K-means clustering, hierarchical cluster analysis, HCA, expectation maximization, visualization and dimensionality reduction algorithms. Within it we have principal component analysis, PCA, kernel PCA, locally linear embedding, LLE, T-distributed stochastic neighbor embedding, TSNE. And finally, the association rule learning algorithms include a priori, ACLA. So this is the end of the first part of this presentation. Topics we have covered so far: machine learning, the definitions, advantages of machine learning over traditional programming approaches, different types of machine learning systems. In supervised learning, we talked about classification and regression algorithms. We also talked a bit about unsupervised learning as well. In part -2 of this presentation, we will try to cover a lot more fundamentals on unsupervised learning. See you there. Oh, if you find this video is helpful, then don't forget to give it a thumb up. Also, if you have any questions about the topic we have discussed, ask me in the comment section below, and don't forget to subscribe. It will be helpful to create more contents like this.